An object at rest is let go from point A. What is its speed at point B? Vertical position of point A is 20 meters above the zero level. Vertical position of point B is equal to 0 meters above the zero level. Speed at point B is what we are asked to find. So you have no friction, no air resistance. Ignore presence of any non-conservative forces like friction. As it travels from point A to point B, it increases its speed. Kinetic energy increases, but what goes down? Potential energy. So you say total energy at A equals total energy at B. Total mechanical energy at point A is kinetic energy at point A plus potential energy at point A. And that should be equal to kinetic energy at point B plus potential energy at point B. What is KEA? It is the energy due to motion at point A. The object is at rest, right? So the kinetic energy at point A, it is equal to 0. How about potential energy at point B? This is the zero level, and this is 20 meters. At zero level, potential energy at point B is mgh, and that is also equal to 0. So you can set potential energy at point A equals kinetic energy at point B. So all the energy it had at point A is now converted to energy due to motion, kinetic energy at point B. What is the expression for potential energy at point A? It is mass times magnitude of the acceleration due to gravity times the vertical height from the zero level. What is the position of point A with respect to the zero level? It is 20. And what is kinetic energy at point B? It is 1/2 mass times speed at B squared. So immediately you see that mass, if you divide both sides by mass, you see that G times 20 is equal to speed at B squared divided by 2. Multiply both sides by 2. Why? To get rid of the fraction. So you get 2 times G times 20 is equal to speed at B squared. So substitute the numbers that you know. 2 times 9.8 times 20 is equal to speed at B squared. So what is speed at B? Square root of 2 times 9.8 times 20. If you do the calculation, you will see that it is 19.8 meters per second. What is the magnitude? 19.8. What is the unit? Meters per second. Speed at point A is 0 meters per second. It has 0 kinetic energy at the start. So there is no energy due to motion at the start. What is the vertical position of point A? It is 20 meters above the zero level. Remember, it is you who set the zero level. You can set the zero level at any point you want. It has non-zero potential energy at the start. How about at B? At B, you have speed at B, but the vertical position of point B is 0. It has 0 potential energy. That means energy due to position is 0. So you go back to total mechanical energy at point A equals total mechanical energy at point B. Sum of kinetic energy and potential energy equals kinetic energy and potential energy at point B. What is the expression for kinetic energy at point A? 1/2 m speed at point A squared. What is the expression for potential energy at point A? Mass times gravity, acceleration due to gravity, times height of point A from the zero level. What is the expression for kinetic energy at point B? 1/2 m speed at B squared. What is the expression for potential energy at point B? Mass times acceleration due to gravity times vertical height of point B from the zero level. Divide both sides by mass, get rid of the mass, multiply both sides by 2 to get rid of division by 2, and you get this expression. And into that expression, we substitute the quantities that we know. Speed at A is 0. It was let go from rest. Acceleration due to gravity, the magnitude is 9.8. What is the height of point A? 20. What is speed at point B? We don't know. What is the acceleration due to gravity? The magnitude is 9.8. And what is the height of point B from the zero level? 0. So when you substitute all these, speed at point A, 0. 2 times 9.8 times 20. Speed at B, we don't know. And then 2 times 9.8 times 0. So that's what I did here. 392 equals VB squared plus 0. 392 equals VB squared. Square of the speed is 392. So this is where some of you lose points. You forget to take the square root of 392 to get the speed at point B. So please don't forget this step. Take the square root to get the speed at point B, and that is 19.80. What is the unit? Meters per second. And this is George Mathew signing off. Good luck.